Okay, the next question is basic eigenvalues. So inside here, this is a linear algebra question rather than a probability one. So it's kind of fun to mix it up a bit. So we have this following matrix here, -5, 2, -7, 4. So it's a 2 by 2 matrix. And there are two eigenvalues, a and b. What are they? Find the answer in the format of a squared plus b squared. Okay, so that's pretty straightforward. What we want to do is we want to get it into the characteristic equation. Then we would want to solve for what the eigenvalues are. So essentially what we do is, let me draw this out so that's more clear. Or maybe I'll do text. So if I have a characteristic equation, I would want something like this form. My original matrix, let's call it A, and I would want the identity matrix times the lambda value. Let's say times lambda equals 0. So this is my what I have here. I have the determinant and I have each value minus I times lambda on the diagonals. And then what I do here is because it's a determinant and it's a 2 by 2 matrix, I could just simply find the determinant by taking the diagonals and taking their differences. So I would have -5, negative minus lambda, 4 minus lambda times together, subtracted by -7 and 2, which would be plus 14 over here. So I get to this expression. Doing a bit of simplification, I get that my characteristic equation is lambda squared plus lambda minus 6. I solve using normal formula and I get that it's either 2 or -3. And these are basically my eigenvalues I'm trying to find. And it's asking me for the format of a squared plus b squared, so I get 13. And then usually this question is pretty straightforward. We end it off with 13 and that's good enough. But usually in most questions, linear algebra question, we would then move on to finding the eigenvector. I typed it wrong. It should be eigenvector here. I'll fix it here. So it should be eigenvector. So when we're trying to find eigenvectors, what we do is this is first writing it in the characteristic equation I talked about earlier, a minus lambda I, and then this v over here is our eigenvector that we're trying to find, and we're setting that to be 0. And then first it's going through the steps of like what I did, subtracting it so that we get this matrix, and then we want to find what xy vector gets us to the 0, 0. So what we do here is we want to use Gaussian elimination to simplify this matrix over here. And then doing a bit of Gaussian thing, we find that we get it to this form of where the bottom row is definitely 0, 0, and we get something on the top, 1, -1. It should be always in this form. So basically translating that back, it basically means 1x minus 1y because we see here that it's the top part times this part is equal to 0. So then that's what the equation we have. And just rearranging that, we get x equals y. So it's pretty straightforward. This would be our coefficient, which is the eigenvector we're looking for. And once we have the eigenvector, we can do stuff like similarity matrices, and also diagonalization. Okay, let's leave it off here today.